Hello there. Today's lesson is 1.2a, Basics of Functions, and this starts off our chapter 2. All of this is review, so it should be a short and sweet. So first of all, we're going to be finding the domain and range of a relation. We're going to determine whether a relation is a function. We're going to determine whether an equation represents a function, and then we're going to actually evaluate a function. And again, I know you've done all these things before, so let's just quickly review. First off, we have a relation, and a relation is any set of ordered pairs, x, y, ordered pairs. The set of the first components of the ordered pair is called the domain. The set of the second components of that ordered pair is called the range. So we know that the x goes to the domain, and y'all, in case you haven't heard this before, x and y, alphabetically, x comes before y, and alphabetically domain comes before range. If that helps you remember, x goes with the domain and y goes with the range. Hopefully that will help you. So if I give you a set of ordered pairs, you have to determine what the domain is and what the range is. So all of the first elements will be, we have 0, and then 10, 20, 30, and 40. And then for our range would be the second elements, which are 9.1, 6.7, 10.7, 13.2, and 21.2. That's all it is. Okay? Now, how do we know if a relation is a function? A function is a correspondence from the first set called that domain and the second set called the range. And you have to remember that each element of the domain corresponds to exactly one. This is the key steps, key words. Exactly one element in the range. That means one and only one. That phrase, exactly one in math. That's what it means. So you also have to be able to look at a set of ordered pairs and tell me whether or not it is a function. So when you look at that, the first thing you do, y'all, look at the x's, 1, 3, 6, 8. Do those numbers repeat? None of those x numbers repeat. And since they don't repeat, then I know that it is a function. Okay? If they repeated, look at the y values. And if the y values are different, then we don't have a function. Okay, so that's from a sort of set of ordered pairs. From an equation, okay, all you need to do is solve that equation for y. And as long as it's only equal to one expression, then you're good. Or only not more than one value of y can be obtained. So look at this example. Determine whether the equation defines y as a function of x. So the first thing you want to do is solve that for y. So when I solve it for y, I'm going to start off by taking that x squared to the other side. So I'm going to have y squared equals 1 minus x squared. Then I'm going to take the square root of both sides. And what might get you into trouble if you do not remember that when you take the square root of both sides of an equation, you have to remember the plus or minus. So that is the equation solved for y. And because that plus or minus is there, that would give us two different y's for whatever x I plug in here. So that is enough to tell us that no, this is not a function, that this equation does not represent a function. Okay. I also have to make sure you know what function notation is. Okay, the special notation f of x. It is read f of x or f at x. More often, it is read f of x. And it just means it represents the value of the function at the number x. And I think y'all have done this before. But 2 examples, and then we're done. Okay, first off, evaluate f of x if f of x equals x squared minus 2x plus 7, evaluate f of negative 5. So I'm going to go plug negative 5 in everywhere I see an x. So the best way to do that, rewrite it. I don't know why I blocked. Oh, no, I did. We're trying to find out f of negative 5. So anywhere you see parentheses, anywhere you see a variable in the original expression, put parentheses. And then instead of x, we're going to go plug in negative 5. So then we find out that f of negative 5, put it in your calculator in one fell swoop, y'all. You don't have to show me any intermediate steps. These calculators you use on the ACT, so that's what you need to be able to do. Okay, so know your calculator and know how it works. And when you do, you're going to find out that f of negative 5 equals 42. Okay, last problem here. This time, we're going to evaluate a function. If f of x equals the square root of x plus 3 minus 8, then evaluate m minus 3, f of m minus 3. So this time, I'm not taking negative 5 or a number, okay? I'm taking an expression, and I'm going to plug it in where I see x. So I hope you understand that means I'm going to have m in my answer somehow. So first and foremost, I'm going to have f of m minus 3. Okay, and again, I'm going to write it, and normally I would put it in parentheses, but this time I actually put it in a different color. Okay, so where I saw x, I put m minus 3. Everything else looks the same. And when you simplify that, the 3's cancel out, leaving me with just the square root of m minus 8. And that's our answer. So we found domain and range, and we evaluated functions. Make sure you write down what you need to remember to master these concepts. Thank you so much for watching, and y'all have a great day.